Welcome to solverfy.
Hi there. So in the problem, it's given that the transmission lines can carry current of 100 amperes or more, and the people who are living near the transmission lines are worried if the electromagnetic fields created because of the motion of current through this transmission line will have some health uh, effects on them. So let us explore, let us try to find the magnetic field created because of this transmission line on the ground, which is at a distance of 8 meters from the ground. And let's see if it causes any danger to the people living near the transmission lines. So let's imagine that this is the ground level. So this is your ground, it's the G. And let's say this is the transmission line, which is at a distance of 8 meters above the ground. It's given that some amount of current is flowing through this transmission line. So the current that is flowing through the transmission line is 150 amps. So the constant current of 150 amps is flowing through the transmission lines. And so we are required to find the magnetic field uh, on the ground because of the transmission line. So at a distance of 8 meters. So this is a problem of magnetic field near a long straight current carrying conductor. And for a long straight current carrying conductor, so if you have a long current carrying conductor, if some current I is flowing through this conductor, and if you want to find the magnetic field at this point, which is at a distance of, let's say, R from this conductor, then the magnetic field is given by B equals mu naught, which is the magnetic permeability, times the current divided by 2 pi and the distance at which you want to measure the magnetic field. So this is the formula for the magnetic field because of a straight current carrying conductor at a distance r from the conductor. So let's apply that formula here. So we have our B equals mu naught I divided by 2 pi r. And so we know what is mu naught. It's the magnetic permeability of the free space, and its value equals 4 pi times 10 raised to negative 7 times the current, which is given to us. It's 150 amps divided by, again, 2 pi times the distance at which we want to measure the magnetic field from the current carrying conductor. And in our case, the distance is 8 meters. So I write 8 here. So if you cancel this, so you get 2 here. So you have 300 divided by 8 times 10 raised to negative 7. And if you solve this, the answer comes out to be 37.5 times 10 raised to negative 7, and the unit is Tesla. So this is the amount of magnetic field generated by, so just remember it's negative 7. So this is the amount of magnetic field generated by the transmission line, which is carrying 150 amperes of current at a ground at a distance of 8 meters from the line. So 37.5 times 10 raised to negative 7 Tesla. So it's given that the Earth's magnetic field is 0.5 Gauss. g. And we know that the relation between the Gauss and Tesla is, so 1 Gauss equals 10 raised to negative 4 Tesla. So if I convert the Earth's magnetic field in the units of Tesla, so I'm going to have 0.5 times 10 raised to negative 4 Tesla. So this is my Earth's magnetic field in terms of Tesla. So now I know the magnetic field because of the transmission line. I divide that magnetic field by the magnetic field of the Earth. So the magnetic field because of the transmission line which we found is, that is 7.5 times 10 raised to negative 7. Make sure that when you are dividing these two quantities, the units should be same. So the B should be in Tesla, and BE, which is the magnetic field of the Earth, should also be in Tesla. That is the reason we converted the Earth's magnetic field in the units of Tesla, so which was zero point 0.5 times 10 to the power of negative 4. And if we solve this, we'll get the answer to be 7.5 times 10 to the power of negative 2. So it's which is in other words it's 0.00. I'm sorry, it's gonna be 0.0 7.5, and if you take the percentage, it's gonna be 7.5%. So we see that the calculated magnetic field because of the transmission line is only 7.5% of the Earth's magnetic field. We also notice that the Earth's magnetic field is very less. It's only 0.5 times 10 to the power of negative 4 Tesla, or in other words, it's zero point 0.5 Gauss, uh, which doesn't affect us. We are not, our health is not affected because of the Earth's magnetic field. And moreover, the magnetic field because of the transmission line is 7.5% of the Earth's magnetic field, which is again very less. So it's not going to have any effect on human health. Thank you very much. Hope